Hello everyone, my name is Sedu Vinayakan. I am a PhD scholar in the Department of Civil Engineering at IIT Madras. I will be conducting live interactive sessions for the 12-week course on Integrated Waste Management for a Smart City offered through NPTEL. The purpose of these sessions is to help the learners of this course to understand the concepts better and also to help them solve the assignment problems that will be released each week of the throughout the duration of this course. And what we will be doing is we will look at some of the concepts covered. So we will look at some questions that are related to the concepts covered and then see how to answer these questions. And this particular session is a demonstration of how we will be doing these live sessions later on. So this is based on the prerequisites of this course. So this is week 0, where we will look at some problems that are based on the prerequisites. And so the format of these questions that we'll be looking at will be similar to the format of questions that will be asked in the assignment. So the typical format is multiple choice questions. So where we'll have a particular question and then we'll have a set of 4 options or choices from which we'll have to choose the correct answer. And sometimes we'll have to choose, there will be only one correct answer, and in some cases there will be more than one correct answer as well. And so with that, we will get started for this particular session. The first question is, which was the first city to have an established system of waste removal? So the 4 options are London, Paris, Athens, and Delhi. So this is the typical MCQ question that we will be looking at, right? So this question is based on the history of solid waste management, and so the correct answer to this is option C, Athens. So if you look at the history of waste management, then in the ancient times, what people were doing is they were the food scraps and other kinds of waste were simply thrown onto the streets. So there were these huge uncontrolled dumps or piles of wastes that you could see in and around these cities. And what this meant was these became breeding grounds for animals and other insects, and that helped cause various diseases. And in Athens, around 320 BC, the first known law that forbid this kind of practice was first established. And therefore, the correct answer to this question is Athens. Moving on to question number 2, which of the following is the correct waste hierarchy of the 4R principle? Right. So, for those who do not know about the 4R principle, so from the options you could see the 4R's stands for reuse, reduce, recycle, and recovery. Right. But the order of these methods of waste management uh, is not is only correct in one of these 4 options, right? And that is what the question is asking us to choose the correct hierarchy of the 4R principle. So what is the correct hierarchy? So if you want to say the correct hierarchy, it is based on the most preferred way of managing waste to the least preferred way of managing waste, right? So if you look at that from that perspective, then the correct hierarchy would be option B. Uh, so reduce is the most preferred way of dealing with waste. Then reuse, followed by recycle, and finally recovery. So what do these different methods or R's mean? So reduce means to generate less waste, right? So if we generate less waste in the first place, then we will have less waste to deal with, right? So the ideal scenario is to generate no waste at all. But however, we know that it's not possible uh, to generate no waste at all. So we will generate some waste. However, we can try to minimize or reduce the amount of waste that we generate. Right? And so that is the most preferred way of dealing with waste to not generate more waste. Then the second most preferred way of dealing with it is to reuse products and materials, right? So in their original form. So for example, instead of buying a water bottle every time we go out or we travel, we could carry our own water bottles and then refill it whenever we need it, right? So that way we are not wasting or throwing away products right after using it once or twice. So that way we generate lesser waste. So that is the second most preferred way, that is to reuse. The third way is recycling. So in recycling, how is it different from reusing? Is in reuse, as I said earlier, we would be using the products in their original form again and again. Whereas in recycle, we process it, right? So we spend some energy and money and recycle the products so that it can be used again, right? And finally, recovery. So when we are done with it, so we can't do anything more with the product, so we are going to dispose it off. So in that case, still we can recover some useful materials or components from those uh, disposed items as well, and that is the recovery part. So the correct order is option B. So moving on to question number 3, in which year did the government of India implement the latest solid waste management rules? So the four options are 2010, 2006, 2016, and 2005. So if you follow these guidelines that are out there, so you would know that the latest ones are the latest one was released in the April of 2016 by the Union Ministry of Environment, Forests and Climate Change for solid waste management, right? So if the previous version of these rules were in place from 2000, from the year 2000. So it has taken around 16 years for the new rules to come up, and these new rules cover many things, from what are the duties of the waste different waste generators, and what are the duties of the different authorities, and that it also talks about the time frames for the new rules to be implemented, and also about the periodic reviews that will be conducted by different authorities at various levels. So that is the new waste management rules, and it came into effect or it was released in 2016. So that is option C, which is the correct answer. Moving on, question number 4. Which of the following can be the correct order of integrated waste management strategy? So again, we have four different components or elements in this integrated waste management strategy. So as we see from the options, so we have source reduction, recycling, disposal, and treatment. Right. So we have different orders in these four options, and we'll have to pick the correct one. So the correct order is in option A. So source reduction followed by recycling, then disposal, and finally treatment. So we already saw one particular order in the 4R principle, and this is not very different from it. So we can actually see some similarity with respect to the 4R, right? We can map these to the 4Rs. So for example, source reduction can be mapped to the reduced part of the 4R, recycling maps to recycling, and so on. So similar to how we arranged the 4Rs, so in a similar way, if you look at it, so the correct order is given in option A. And question 5 is why mixed plastics are difficult to recycle. The options are because it is very hard material, because it is very adhesive in nature, because of different types of polymer resins, and because of different sizes of plastic. So before we understand why it is difficult, so what do we mean by mixed plastics? So mixed plastic means it is the combination of different kinds of plastic materials, right? So there are different types of plastics, right? And it is the combination of these in the same stream of waste. So we have all kinds of plastics in the same stream of waste. And when we are trying to recycle uh, that particular these plastics from that particular stream, it is very difficult. Why? Because uh, because of option C, right? So it is the different types of polymer resins that is being the reason for this difficulty in recycling. So if we look at plastics, different kinds of plastics require different types of polymer resins for their production, and each of these different types of polymer resins have their own chemical composition. So when we have multiple types of plastics together, it's hard because the chemical composition of each of them is going to be very different from each other, and therefore that adds to the challenge uh, when we are trying to recycle them. So what is the way forward? It is to separate these, right? So mixing them together is causing difficulty. So what we do is we try to separate these into their own kinds, but that requires more effort and time, right? So that is the other part of it. Uh, why this is happening? All right. So moving on to question 6, why the recycled paper is banned for use in food containers? Options are because it may create contamination, because it creates a lot of spaces, because paper can be used only one time, and because paper is very thick and can't cover the food containers. So the correct answer to this question is option A. It may create contamination. So that is the reason why recycled paper is banned from being used in food containers. And not only from this contamination part, which is a serious health issue, we also have to look at the other part in terms of the economics of this recycling of paper. So if you look at the cost it takes to transport raw paper pulp, and the cost for transporting scrap paper, in most of the cases, the former is costs lesser, right? And also, if you look at the total cost of recycling paper, most of it is accounted by the collection, sorting, and the transportation processes. So both from this point of view, from the economics point of view, and as well as from the health perspective, it is not desirable to use recycled paper, and therefore its use is banned in food containers. And moving on to question number 7, what is the full form of ISWM? So we have 4 options: innovative solid waste management, international solid waste management, integrated solid waste management, and finally institutional solid waste management. So I think most of you could guess what the correct answer would be from the title of this course. So it is option C, integrated solid waste management. So that's very straightforward. But what does it mean to say an integrated solid waste management system? Right. So if you look at a solid waste management system, there are multiple components to it. Right? So there is the generation of the waste, then there is collection of waste, then separation of these wastes into different types, and then transporting it and treating the waste, and finally disposing or dumping the waste. Right. So these are some of the different elements that make up the solid waste management system, and the integration of these elements together into one cohesive unit is what we refer to as an integrated solid waste management system. All right, and moving on to question number 8, the process of decomposition of biodegradable solid waste by earthworms is called. The options are incineration, shredding, vermicomposting, and pyrolysis. Right? So we need the terminology that describes this process of decomposition of solid waste, of biodegradable solid waste by earthworms, right? So how do we go about answering this? If you do not know, I'm sure most of you would heard of this process and the terminology, but in case we do not know it, how would we answer it? So we can try to uh, eliminate the options, right? So based on our understanding, what could not be the correct answer, and by that way we can narrow down our options and the correct one. If you look at option A, incineration. So what does it mean to incinerate? It is to combust, right? To burn things. So incineration is to combust the waste products. So that can't be the answer. So A is ruled out. So B is shredding. What does shredding mean? Shred means to cut down, right? So it is to cut the waste into smaller sized particles. And so that can't be the answer. So we have vermicomposting. Okay, we don't know what vermicomposting is. So we leave that for now. Going to pyrolysis. Pyrolysis means it has to do with heat, right? So what does so pyrolysis actually stands for composting, but with the help of heat, right? So that is also not the answer. So the only option that we are left with is vermicomposting. So that's what is the terminology for this process of decomposition taking place with the help of earthworms for biodegradable solvents. And moving on to question number 9, which of the following represents the conventional waste management hierarchy? So we have three different processes, right, that are jumbled up in these different options. So collection, transportation, and disposal. And we have one option, none of the above. So if you look at a conventional waste management system, what is different from the modern uh, techniques and processes is that in conventionally waste was just dumped into dump yards and landfill sites. So that was the conventional way of handling waste, right? So there is no recovery or recycling as we looked at earlier, right? So it is just dumping or just disposing the waste. So in that case, what is the correct order? So logically, if we think about it, what happens? So generally, waste is generated not at a particular location, right? So it is distributed. So if you look at different households in a particular region, so each of those households is going to generate waste. So the waste is generated. Source of this waste generation is distributed across a region. So we need to collect the waste from all these source locations. So collection has to be the first part. Then we'll have to dispose these collected waste. But the disposal or the dump site is going to be somewhere uh, out in the outskirts of the city, right? So because of the odor and also the area requirement of the large land area, it's not going to be anywhere inside the city, but on the outskirts. So there is a uh, separation or spatial separation from these collected waste and the disposal site. So we need transportation. So these collected waste are transported and to the site, and finally it is disposed of. So the correct order is option A, collection, then transportation, and finally disposal. So that's the conventional waste management hierarchy. So question number 10, which of the following combustible gas is released during the anaerobic degradation of organic solid waste? The options are water, carbon dioxide, methane, and hydrogen sulfide. So the correct answer to this is option C, methane. So if we look at an anaerobic degradation or anaerobic digestion of organic solid waste, so in that process, there are multiple end products of it, right? So methane, carbon dioxide, and water, all these are released as products at the end of the anaerobic degradation. However, the question is about the combustible gas that is released in this process. So out of these three, the only combustible gas is methane. Therefore, the answer to this question is C, methane. All right. So moving on to question 11. So the questions that we saw so far, the questions 1 to 10, are of the type multiple choice questions where we had a single answer, single correct answer to each of those questions. As the questions that we are going to look at from now on, 11 to 15, are of the type multiple select questions. So where we'll have again four options. However, there can be more than one option which can be correct for that particular question. So we'll have to select all those multiple correct answers to that question. So the first one of those type is which of the following is are a solution for solid waste management? The options are waste to energy and fuel, waste to compost, recycling and reduction, and none of the above. So the right answer is all the three A, B, and C are solutions for solid waste management. So we are trying to do different things in these different solutions, but these are all methods or ways of handling solid waste. Right. So in option A, waste to energy and fuel, we are trying to convert the waste materials into useful forms of energy and also fuel, such as refuse derived fuel. Right. So we'll convert waste materials into fuel, into forms of fuel that we could then later use in different processes, or directly convert this waste into energy, into generally heat energy that can be used for generating electricity and so. And in option B, it is waste to compost. So in so we it is mainly to do with organic waste, right? So we try to do compost with that. So what does that mean? So it is the natural biodegradation of these organic waste materials. And then in C, it is recycling and reduction. So we already talked about these methods, right, in the 4 hours. So these are different ways or different solutions that are available for handling solid waste. So question number 12, which of the following wastes can be recycled? A, plastics, B, food, C, glass, and D, none of the above. I think this is a pretty straightforward one, right? So the answers are A and C. Plastic and glass, as we know, are recyclable materials. However, food is not. Why? Because though it's organic, it is biodegradable. We can do composts with it, but um, it is not recyclable. We can't recycle food back into again useful food, right? Uh, so that so the correct answer to this is only A and C. Question 30. The term municipal solid waste is generally used to describe which kind of solid waste? So A, biomedical waste, B, kitchen waste, C, radioactive waste, and D, mixed household waste. So if you look at solid waste, again, there are multiple kinds of waste that we can call as solid waste. So some of the options are given here, and so there are others as well. So among these that we have here, what goes or what can be classified as municipal solid waste are options B, kitchen waste, and option D, mixed household waste. So these can be termed as municipal solid waste. However, A and C cannot. So what do we mean by municipal solid waste? You can think of it as whatever waste that is being generated from a typical municipality, right? So what do we have? We will have different residences, right? So in a municipality, and all the waste that you can think of generated by these households in that particular municipality, we can classify them as municipal solid waste. So, what are the other kinds of solid waste that we can have? We can have litter, right? And we can have yard waste. We can even have hazardous waste that are coming from these households. So, for example, we have hazardous materials in the batteries that we use from the for the different appliances. So even those can come under municipal solid waste. Even construction and demolition waste from these regions. So they can also be termed as municipal solid waste. All right. So moving on to question number 14, which of the following is are a biodegradable waste? Yard waste, single-use plastic, agricultural waste, and food waste. So what is a biodegradable waste? So it has to be naturally it should be naturally broken. It should be able to naturally broken down uh, by natural processes, right? So what do we need for that? The waste has to be made up of organic material, right? So organic waste can be biodegraded, right? So if we have to look at these options and then see which are biodegradable, then we'll have to look which of these are organic waste. So from that clue, we can say options A, C, and D are all organic wastes and therefore can be biodegraded. Whereas B, single-use plastic, is not organic and hence it cannot be biodegradable. And finally, the last question for this particular session is which of the following is true about aerobic bacteria? So what do we mean by an aerobic bacteria or an aerobic any aerobic organism or aerobe for short is an organism that survives or thrives in an oxygen-rich environment, right? And it consumes some organic material as food. So with that information, if you look at these options, then the true statements about anaerobic bacteria are option B, it consumes organic matter as its food, and option D, it flourishes in the presence of free oxygen. So these are true about an aerobic organism, and therefore it is true for anaerobic bacteria. And the other options, option A, is kind of the opposite of option B, therefore it is false. And C is it produces methane after the complete degradation of organic matter. So methane, we saw methane is produced when organic matter is biodegraded, right? In one of the earlier questions, however, it is not true for aerobic bacteria because methane is produced when biodegrade at the end of biodegradation of organic matter in an anaerobic environment, right? It is not for aerobic bacteria. Therefore, C is a false statement. So the right options are only B and D, right? So that concludes the set of questions that we have for this particular demo session or the week 0 of this course, right? And we will continue this kind of session, so which will be happening live with the students, and so we'll have interactive sessions. So we will go through the concepts behind these different questions, kinds of questions, and try to see how to answer them so that it will be helpful in solving the assignments. So we'll meet again in the live sessions starting from the coming week. Thank you.